So, knowing this part, knowing what is our task and general structure of the code, let's go into to our Python code as well. So we are going to work today in a way that on the left side we see the Python code, on the right side we see the code that was implemented on the polyscope. So let's focus on the task number 1, which is moving from some random initial value to the initial value of our trajectory, which is denoted as start pose. Okay. So over here you see the start pose, you see the desired pose. Again, start pose is point B in our paint, and desired pose is point C in our graphics that I made in the paint. Because we are just doing a minimum jerk with translation, we do not want to change the orientation. The orientation values are being stored in the orientation constant variable, and here we have the first control loop that we are going to run. So over here on the top, as you can see, I implemented a small lookup table, lookup list that you can see which code to run first. So first we run the polyscope program till a pop-up window appears. Then we are going to run Python code on the external device. And then we click continue on this polyscope. What I mean by that is we click continue on the pop-up window that's going to appear. So step number 1, we run the polyscope program. The joints are the joint variables are being initialized to some to the initial joint readings from the robot, and we change the output boolean register 0 to false, and then we have the window that pops up and tells us, do you want to continue? We do not click the continue button because at this point the program has stopped and it's waiting for our action. Remember, this is the most important part. We set the boolean register to 0 to false. Later on we run the code on the Python, which executes this control loop over here. This is infinite loop unless this condition is satisfied, but because we set it to false, it is not satisfied, and that's why this loop is going to loop infinitely and wait for the value of output bit register 0 to change. In order to do that, we click continue on our pop-up window, which allows us to execute the main robot code, which says output boolean register 0 is equal to true. Once this part of the code is executed, the output bit register 0 is changed to true, and we exit this loop and we enter to the execution of move_j stage. What I didn't mention before, we set mode equal to 0. This is the value of the task that I mentioned before. So if we look at our paint, this is mode 1, mode 2, and not visible, and this is mode 3. So initially we set it to 0, but as we can see over here, we are going to execute mode number 1, which is task number 1. So very important part, we look into the thread. So as we mentioned before, thread is a program that runs parallel to the main program and that reads the values of the registers. It is important to mention that we implemented the minimum jerk in Cartesian space. What does it mean? We took the starting point of our TCP, X, Y, Z, and 3 values of the orientation, and we also took the last and also the pose of the desired point, also in Cartesian space. But servo_j works with joint values, okay? So in order to be able to translate from Cartesian space to the joint space, we need to do inverse kinematics. You can do it by hand, but obviously it's not going to be as precise as what Universal Robots has to offer for us. So actually Universal Robots provide us with a function called getInverseKinematics. It takes as an input the pose, meaning X, Y, Z, and 3 values of the orientation. And if you look into documentation, it also wants some kind of approximation of the joint values. You can read more about it in the documentation, but what I recommend is just to do what I did over here. We can see that the thread is running continuously parallel to the main program, and the poseRegister.script, this is a part responsible for reading the values from the registers. Over here we can see what exactly this program contains. So for each 6 values, we read the 6 values stored in the registers, and each of those values corresponds to one of those values in the Python. Those are the values that we are sending. We also set the variable mode to be equal to read input integer register 0, which is over here, and this will change the value of our flag. So at this point, if we look over here, we are at the point of executing move-j. We set the mode equal to 1, we send it to the robot that we change it to 1, so the mode over here will be changed. And we also send, using those lines, we first convert it to an appropriate format and we send it to the robot the initial pose. By sending it, the pose register.script is going to be updated, the values of the registers will be updated, and the TMP is going to be changed. This value is going to go, those values are going to get inside the function of the get inverse, and we are going to get the corresponding joint values. So because right now, as we can see over here, we are in mode 1, we are going to enter this loop, and the joint values are going to be read from the thread over here. So again, I know this might be very confusing, especially with my explanation, so feel free to write a comment if something is unclear. But we send those values using the registers to the robot. Using the thread, we read those values in postregister.script. We store those values in a variable called TMP. We put this value in the get inverse kinematics function, and in that way we obtain the joints. We also read the mode, which tells us in which part of the task are we at the current stage. So coming back to our robot main program, we can see that now we are in loop mode 1, right? Because we change it over here, sending mode 1, and the move-j is going to be executed, where the joints are the joints that were sent, calculating based on this initial TCP pose. We then wait till this value is executed. Okay, so as we can see over here, while true, waiting for move-j to finish, and we say that the move-j is finished only if output bit register 0 is equal to false. As we can see, this is exactly what we did over here. We only after move-j finishes, the output boolean register 0 changes to false, which allows us to conclude that this part of the motion has been completed. And in this way, we finished mode number 1, and we are going to proceed to mode number 2. And I'm going to talk about this mode in the next video.